Hi, I'm Mike Siegel. I'm an astrophysicist. I write about science for ordinary times, and this is the throughput. So my last video on astronomy and movies did quite well. I got a lot of positive response for it. So today I'm going to do something a little bit again. But instead of talking about someone that got it right, I'm going to talk about someone that got it wrong. And that someone is probably my all-time favorite TV show, Doctor Who. I have watched this since the 1980s. I've loved the new series. So it pains me to make them the target, but the episode in question is a problem. It's a 2014 episode of the new series called Kill the Moon. In this episode, the Doctor, his companion Clara, and one of the children from the Coal Hill School where they're at visit the moon in 2049, find various scary things happening, and there's a big moral dilemma, and they have to solve it. So let's dive right in. So right off the bat, we have a problem. The episode starts with an old school space shuttle crashing into the moon. But the shuttle actually would be really unsuited to this kind of moon landing. When you land a spacecraft on the surface of any astronomical body, the main thing you're worrying about is gravity. Gravity is what attracts you to that body, but it's accelerating you as you descend. And so if you don't do something about it, you're going to not just crash land, you're going to crash catastrophically, and you won't survive. We've had incidents in the space program where objects failed to slow down on re-entry and crashed into planets and moons with disastrous results. When landing things on Earth, we take advantage of the fact that Earth has an atmosphere, and we use that to slow things down. You deploy a parachute, or you use heat shields that compact the air in front of you. And what that does is it uses the resistance of Earth's air to slow your velocity down and bring your spacecraft in for a relatively gentle landing. With the space shuttle, what it does is it comes in like a traditional capsule using the air to slow it down, but then it uses those wings to glide in for a nice landing on an airstrip. Now on the moon, you don't have an atmosphere. So those wings on the shuttle are not going to be useful. They're just dead weight. If you want to land successfully on the moon without crashing, even at normal gravity, you need to use rocket thrusters. All our missions that land on the moon use thrusters. The Apollo astronauts used it. There was recently an Indian mission that failed because the thrusters failed to ignite and the space probe crashed catastrophically into the surface of the moon. The space shuttle does not have re-entry thrusters, and there's nothing in this episode or this scene that indicates that it's been retrofitted with them. Now, maybe if you loaded it up with fuel, you could use the engines in its rear to come down for a landing on its tail. That would be really difficult to do and probably destroy the vehicle. But if you're in a desperate situation, sure, you could do something like that. But coming in like it's landing at Edwards Air Force Base, that's just not going to work. You're just going to destroy the shuttle. One other thing, since the shuttle has unpowered re-entry, it's not using rockets to slow itself down, and it can't use parachutes or gliding to slow itself down, they should all be floating right before impact. The shuttle doesn't have artificial gravity, and they make a specific point that this is a shuttle taken from a museum, so it wouldn't have artificial gravity. And when you're in free fall, it doesn't matter how strong the gravity is. Whether the moon's gravity is increased or decreased doesn't matter. You're in free fall. So you're just going to be floating, just like you do on the Vomit Comet, just like you do anytime you're falling.
We should all be bouncing about this cabin like fluffy little clouds, but we're not. What is the matter with the moon?
Nobody knows. Do you know what's wrong with the moon?
It's been on weight. Must be causing chaos on Earth. The tides will be so high that they will drown whole cities.
Yeah.
Now we'll get to the gravity thing in a second, but what the Doctor is saying here is right as far as it goes. The moon's gravity is what drives tides on Earth. When the moon, let's say the moon is over here, the side of the Earth that is closest to the moon is going to feel slightly stronger gravity than the center of the Earth. And that's going to pull that outer edge of the Earth a little bit away from the center of the Earth, sort of stretch the Earth out. Now the Earth is rock, so it won't change shape. But on the surface of the Earth, you have water. And so what that water is going to do, it's going to slosh outward towards the moon. The tide is going to rise. And so we get high tide when the moon is overhead, roughly. On the opposite side of the Earth, the side facing away from the moon is slightly less gravity than the center of the Earth. So that stretches it the other way, and it causes the water to slosh outward to create another high tide. So you have high tides towards the moon and away from the moon. And then that's balanced out because 90 degrees away from each, you have low tides where that water has sloshed away towards the other areas. But the strength of the tide changes. It's not always the same. The tides, for example, will be slightly higher when the moon and the sun are aligned because the sun exerts a gravitational influence on the Earth too. You may remember last year when the Evergreen tanker got stuck in the sand in the Suez Canal. One of the ways they were able to free that was they waited until the sun and the moon were aligned so the tide was a little bit higher, like a foot or two higher than it normally is. And that gave the boat a little bit of extra lift to help it get out of the sand. If the moon's mass did increase, that would significantly increase the tides. And they don't have to increase a lot to start causing catastrophic damage. So why the moon's gravity is increasing, we'll get into that later. But if the moon's gravity did increase, that would actually create a problem for the tides and actually cause the moon to start getting closer and closer to the Earth as the gravitational force between the Earth and the moon increased. Now, just a little touch here. The shuttle shouldn't be smoking. There's no air for things to burn in. But there's actually a little subtle point. I'm not going to knock them from doing this because it is quite subtle. That smoke that you see rising from the destroyed shuttle, it should actually be falling straight to the ground. When you're on Earth, smoke rises. Smoke rises because it's hot and because it's lighter than the air. And so it floats up above the heavier air into the top of a room or whatever. But you're in a vacuum here, no air on the moon. So that smoke is actually going to come straight down. And that is, in fact, what smoke does in a vacuum when we do it in vacuum chambers on Earth. It's a subtle point, not going to take off points for that, but it is something I thought I'd notice.
Lines of tectonic stress.
It's the Mare Fecunditatis. It's been there since the Apollo days. It's always been there.
No. These are much, much bigger. At the moon, this little planetoid that's been tagging along beside you for 100 million years is in the process of falling to bits.
Now, here's a big problem. The moon is not 100 million years old. We know this. The Apollo missions brought samples back from the surface of the moon, and they clearly showed that it was the same age as the Earth. And that's critical to understanding of how it formed, which I'll get into later. But the moon is way older than 100 million years. It's more like 4.5 billion years. But they actually do get one thing right here. The moon has a very small amount of seismic activity. We've had instruments to measure moonquakes since the Apollo missions, and it does have lots of moonquakes, but they tend to be very small. If you started getting really strong seismic activity, large enough to crack the Maria, which is what they're showing here, that would indeed be alarming and would be reasons for scientists to go to the moon and try to figure out what's going on. It would be really hard to break up the moon. The moon has an enormous amount of gravitational energy holding it together, and so we'd need enormous amounts of energy to break that up. But if it did, this would be an extinction level event, because when the moon breaks up, what you have is a whole bunch of debris that is going to start raining down upon the Earth so intensely that it's going to turn the sky white with asteroid re-entries. It would wipe out all life on the surface of the Earth. This is in fact the basis of Neil Stephenson's novel Seven Eves, in which an unknown agent breaks up the moon and humanity has to figure out a way to survive the ensuing Holocaust. Those of you who are deep into Star Wars lore may be familiar with the Endor Holocaust, where fans figured out that after the Death Star exploded, all that debris would have rained down on Endor and caused mass devastation. So they are actually right about the danger if the moon were to break up. Again, it would take tremendous amounts of energy to do so. But if it were to break up, that would be a tremendous danger. And so they do actually get this part right.
You flew because that 1.3 billion tons shifted. It moved. It's an unstable mass.
All right, this is where things start to go badly wrong in the episode. This is the first time the Doctor mentions that the mass of the moon has increased by 1.3 billion tons. 1.3 billion tons sounds like a lot. On the scale of astronomy, it's nothing. The moon weighs 50 billion times that much. In fact, the moon actually gains weight every day. Every day, about 3 tons of micrometeorites and asteroids rain down on the surface of the moon. And in over 1 million years, it will accumulate about 1 billion tons worth of mass. And so 1.3 billion tons is not even going to register on the radar. Now, the Doctor in this scene says the mass has shifted. It's an unstable mass, and that's why Courtney floated in the air. What? That makes absolutely no sense. First of all, again, a tiny fraction of the mass, but let's say it was a lot more mass. Even then, that mass shifting around is going to cause the moon to be unstable.
Sir, it's quite possible this asteroid is not entirely stable. not entirely stable. I'm glad you're here to tell us these things.
You would wobble a bit. You would feel, gravity pulling you in different directions and stumble around. But you're not going to float. The only way you float is if gravity is completely canceled, which is not going to happen if there's no gravitational force. Why would it be concentrated in one place? That just makes no sense. And why does touching a yo-yo cancel it out? I mean, this scene is just bizarrely bad and completely unnecessary. Now, I'll go outside my lane a little bit here. The Doctor calls these spider creatures unicellular organisms or one-cell organisms and calls them bacteria. These are clearly not one-celled organisms. They are multicellular organisms with specialized body parts. Now, they want it to be a parasite on the larger creature that's growing inside the moon. But a large multicellular creature would be a parasite for a creature that large. We would be microscopic to a creature that large. And so you don't need to make them these giant bacteria, which are scientifically impossible. You can just have them be spiders. It's fine. You don't need to pretend they're bacteria. You can just say they're parasites. It's fine.
That lives under the moon.
No,
What?
that doesn't live under the moon. That is the moon.
What the hell are you talking about?
The moon isn't breaking apart. The moon is hatching.
Huh?
The moon's an egg.
Now it's going from bad to worse. The idea here is that the moon is actually a giant egg for an enormous space creature, and now it's hatching. Let's go with that. Why would that increase the gravity? Where is it getting the mass from? Mass, as the Doctor says early in the episode, gravity only increases if the mass is increasing. Where is it getting this additional mass from? If I gave you a chicken egg, it wouldn't increase its mass as the chicken grows inside it, unless there was some osmosis going on, like it's absorbing moisture from the air or something like that. But it has everything it needs inside the egg. If this is an egg for a giant creature, it has everything it needs to grow inside the egg. It doesn't need to absorb more mass. So there's no way gravity is going to increase. The egg's not going to get any heavier because it has what it needs inside. This creature would just consume what's inside the egg, not gaining any mass. Now, you would still have these instabilities on the surface with moonquakes and so forth, but you're not going to increase the mass. And again, 1.3 billion tons is a tiny fraction of the moon's mass. And they make this creature look enormous. It's the size of the moon. So that means what? It's 50 billion times less dense than rock. It's many millions of times less dense than air. This isn't a creature. This is a diaphanous gas cloud. So again, this is where getting all these numbers wrong and just sort of winging it on this throws you off, because it's defying belief here.
Because inside the moon, miss, is a gigantic creature forcing its way out. And when it does, which is going to be pretty damn soon, there are going to be huge chunks of the moon heading right for us. Like whatever killed the dinosaurs, only 10,000 times bigger.
Now, she actually does get this right. If the moon did break up, it would be an extinction level event. And Clara tries to say, well, it's just a shell. What if it's just a shell? It'll go away. Shells don't just vanish in a puff of blue smoke. You may have noticed when a chicken hatches, there are bits of shell left around. Those bits of shell will come raining down upon the Earth. We know that at least the crust of the moon is this shell, and that would be billions and billions of tons of mass raining down on the Earth. Even if only a tiny fraction of the moon's mass is this eggshell, you're still talking about an event that would be so catastrophic it would make life miserable for the survivors. So Clara's argument makes no sense. I actually don't know what they're doing with those nuclear bombs. I've watched this episode several times now, and I still don't know what their plan is. Are they going to use 100 nuclear bombs to blow up the moon? That's not even enough to make a dent in the moon. And so that doesn't make any sense. And even if you could blow up the moon, you just recreated the problem. All that debris is going to rain down on the Earth. Now, maybe they're using those 100 nuclear bombs to kill the creature. But again, the creature is as big as the moon. Unless you're hitting it in a particularly vulnerable spot, you're probably not going to kill it. They're just setting these off on the surface, so most of the blast is going to be directed out into space. What's more, the creature's been on a moon for 100 million years. Or let's say they just got the math wrong and it's been on their moon for 4.5 billion years. The moon gets hit by asteroids, and those asteroids have enormous amounts of energy in them, equal to many, many nuclear bombs. If it can survive asteroid impacts, it could survive 100 nuclear bombs going off on the surface. So either way, this plan really doesn't make any sense.
If you think we should kill the creature, turn your lights off. If you think we should take the chance, let it live. Leave your lights on. We'll be able to see.
They have less than an hour. it takes 24 hours for the Earth to revolve on its axis, so they're only going to see the votes from half the Earth. Because Clara isn't looking at satellite data, she's looking at it with binoculars. It's also not clear this would work. You can see lights from space when you are in orbit around the Earth. There was a famous incident during the Mercury program where one of the astronauts went over Australia and the Australians all turned on their lights to sort of be a greeting to him. But from the moon, where you're 250,000 miles away, you're really not going to see that very clearly, and certainly not through a pair of binoculars.
The chick flies away, and the eggshell disintegrates. Harmless.
It laid a new egg. It's beautiful. Doctor, it's beautiful.
That's what we call a new moon.
All right, so this final scene is where most of the fans lost their minds, and it's really hard to blame them for doing so. There's so much wrong in this scene, I really don't know where to start. First of all, nitpicking a bit here, they shouldn't be hearing the moon break up. It's in space, and sound does not travel in space. And even if it did, it would take 5 minutes for that sound to reach the Earth. Now, this is a common conceit in science fiction, so I'm not going to deduct points for that. But it's one of the many, many things in this scene that is annoying. Second, what happened to that shell? Did it just vanish in a puff of blue smoke? I mean, there's going to be all that shell debris. I mean, the creature came out. Did he eat the shell? I mean, the shell just disappeared? That debris is still going to come raining down on Earth, my friends. It's not going to go away. So they were right that the problem still exists. And finally, it lays an egg as big as itself. Where did that mass come from? The creature was supposedly as big as the moon, and now it's disappeared and it lays an egg as big as itself. Does a newborn chicken lay an egg? So what kind of episode does this grade get? Well, it's going to get a failing one. There are actually things it gets right. It's right about how the moon creates tides, and if the moon's mass increases, that would create a huge problem with higher tides. And it's right that if the moon broke up, that would present a tremendous danger to life on Earth. But on the other hand, it gets really basic facts like the age and mass of the moon wrong. And it's not clear what those 100 nuclear bombs are supposed to do. And the less I say about the ending, the better. But let's break out the red pen and fix this up a bit. Because what's really irritating is that these scientific errors were easily fixed. First of all, forget about gravity. It makes no sense. Massive lunar earthquakes are way alarming enough to get the attention of scientists and alert them something dangerous is going on. I think they conjured up that explanation to explain why the actors aren't floating around because the Earth's gravity is lower. But for 50 years on this show, we had the conceit that we had episodes set on the moon where gravity was normal, and we just rode with it, so I don't know why they had to do that this time. Second, you don't need to be the moon to be a literal egg. Just having a giant creature weighing 1.3 billion tons under the lunar surface would be enough to be scary. And if it hatched violently enough, that could send debris down on Earth enough to cause problems. And such an enormous creature would be dangerous. That would be scary to see a creature that enormous hatching out of the moon. And knowing maybe there are others under the surface. So if you had it just be buried under the surface and just creating lunar quakes, you wouldn't change any of the beats of the story. The story could be exactly the same. The 100 nuclear bombs might actually be useful in this case. And so that's, I think, one of the things that irritates me about the episode, that you could have gotten the science right without really changing the story at all. And I'm nitpicking. I've admitted that I'm nitpicking. But you know what? This is a very unpopular story. And if you read the reviews, the bad science is one of the things that bothers people. On an intuitive level, I think we sense that something is off about this episode. We live in a scientific world. We are surrounded by science. It's around us every day. Lunar phases and things like that are things we deal with all the time. And so I think even if you weren't familiar with why it was wrong, something in your brain said, no, I don't get this. There's something that's wrong here. Yeah, this is a TV show about an alien who travels through time and space in a magical police box. Doctor Who fans have always been willing to suspend disbelief, but we're not willing to suspend it this high. And I think that's why the episode is so unpopular. I'm not saying fixing the scientific errors would have made it a classic, but I think it would have been a lot less unpopular without being punched in the face with that kind of stuff. Now, to cleanse the palate a bit, I'll talk about another Doctor Who episode that talks about the moon. And it actually has some good science in it. And that is the Silurians from the classic series. Now, the conceit of this episode is that there was an intelligent creature that evolved during the time of the dinosaurs. And what they discovered was that an asteroid was about to hit the Earth, and so they went into hibernation to wait out the disaster. But either they miscalculated or the asteroid changed its mind. Asteroids can outgas or change their trajectories by a small amount very easily. And instead of hitting the Earth or tearing away its atmosphere, it went into orbit around the Earth and became Earth's moon. And because their systems were designed to sense the end of the disaster and the disaster never happened, they never woke up until millions of years later, humans accidentally woke them up. Now, here's the thing. The premise of the Silurians is wrong. We know based on its orbit and its composition that the moon was not captured. The scenario that is most favored by the current science is that early in the Earth's history, it was hit by a Mars-sized object, and that threw billions of tons of debris into a ring around the Earth that eventually coalesced to form the moon. And we know this because the moon is the same age of the Earth and composed of the same stuff and so on. But when the Silurians was made in 1970, the capture hypothesis was the favored hypothesis. Most scientists, if you'd ask them in 1970, how did the moon form, would say it's quite possible it was a captured asteroid. It was a decade before the data from the moon landings and other information gave us the correct scenario for how the moon formed. So I give the Silurians a passing grade because even though it ultimately was wrong, it was right at the time. And that's one of the things about science. We deal with what we know at the time. The difference between these two episodes is the Silurians did their homework and got it right, at least as far as the astronomy goes. They got the geological period of the Silurians wrong. But Age of the Moon, when you could Google these things, got it wrong. And so that, I think, is the difference between why I might slam a movie or TV show for getting it wrong and why I might praise a movie for getting it right. Now, I don't know that this video will appeal much beyond Doctor Who fans and so forth, but I hope I talked about some interesting stuff. Next time, we'll get into an all-time favorite of mine to set up even more of these film reviews. And so I think we're going to continue with this series because I'm at least having a lot of fun with it. So until then, I'm Mike Siegel. This is The Throughput. You can find my writing at Ordinary Times. Continue to enjoy science.